Hello, and welcome to week 3 of Pine Tree Programming for grades 6 through 8. We are so excited you are here, and we hope the first 2 weeks of coding with the microbit have been wonderful learning experiences for you and your students. In this lesson this week, students will build a reaction time game while learning how programmers combine variables, loops, and conditionals to create more complex programs. By the end of the lesson, students will understand how to store information in variables, measure time using a timer, and build simple game logic that keeps track of scores. This activity usually takes about 40 minutes, and students will need their microbit and the MakeCode editor open.
First, start with the warm up discussion. Ask students the question, what makes a game fair? Give students a minute to talk with a partner or share a few ideas. You might hear answers like, everyone starts at the same time, or the rules are clear. The timing isn't predictable, or even scores are measured accurately. Explain to students that programmers have to design fairness into their games using code. Things like timers, random numbers, and variables all help make games work correctly. Tell students that today they'll build a reaction game that measures how quickly someone presses a button after seeing the word go on their microbit.
Next on, we move into the mini lesson portion where you briefly review 3 key programming concepts. I'm going to talk about the first concept, and that's variables. With students, explain that a variable is the storage area of a system they learned about in week 1. A variable is a place where a program stores information that can change while the program runs. In this project, students will use variables to track things like reaction time and the best score so far, meaning high score. You can also describe variables as labeled containers, like you have around your classroom, I'm sure, where the computer keeps track of numbers or data. In this activity, students will create variables such as start timer or timer, score, and high score. So 3 variables for this game.
The second concept is loops. Many games run continuously, waiting for players to interact. In MakeCode, the forever loop, found in the Blue Basics section, allows a program to keep running over and over again. This lets the reaction game play multiple rounds without restarting the program. Explain that loops are what allow games and apps to constantly check for player input. The third concept is randomization. In a reaction game, players should not know exactly when the signal will appear. If they could predict it, the game wouldn't be fair or a lot of fun. To solve this, we code a random pause into the program before it displays the word go. This makes each round unpredictable and helps keep the game fair.
Now students are ready to start building their program. Have students open MakeCode and begin by naming their project, Reaction Game. They will then create 3 variables, red section. Tell them they will need to click on Make a Variable, and these should be called timer or start time if they prefer, score, and high score. The timer or start time variable will measure how long it takes a player to react. And this will work with the running time milliseconds shortcut block that's inserted from the Input More drawer. The score variable stores the results of the round, and the high score variable keeps track of the fastest reaction time so far. It can be helpful to remind students that lower scores are better because a smaller number means a faster reaction time. Next, have students begin building the game logic. Inside the forever loop, start by adding a pause in milliseconds. They're going to pick random in the math section between about 1 and 3 seconds or 1,000 milliseconds and 3,000 milliseconds. This will create the unpredictable wait time before the game begins. After the random pause, they will add a show string to display the word go on the microscreen.
When go appears, set the timer or start underscore time variable to running time, ms, milliseconds. So the reaction timer starts fresh each round. Next, students will create a loop that measures reaction time. The program will measure the amount of time it takes when the word go appears and when a player presses a button. For example, the program runs on button A is pressed. Once the button is pressed, the timer stops. At this point, students should store the limited value as the set score running time minus start time, and then display that number on the screen. Show number, score. Explain again that this number represents how quickly the player reacted, but it will also show up in milliseconds. So let them know to divide that number by 1,000. For example, if I pressed A after go, it will show me my speed, 3,892 milliseconds, which is 3.892 seconds.
Next, students will want to add an on start button and add set high score to 5,000, or they can even set it to 9,999. So students have a goal or a threshold for highest score. It's not necessarily a goal, but it sets it to almost so high that any that they get will be definitely the newest high score. So their first try will be their highest score. And then it will reset and reset the more they play. So students will add a logic expression to track the highest score under on button A pressed. Using an if-then statement in the logic drawer, the program can compare the current score to the stored highest score. If the new score is lower, that means the player reacted faster than before, hence the best score. In that case, the program updates the high score variable and can display a celebration icon, such as a trophy or a happy face. This introduces students to an important programming idea of conditional logic, where the computer makes decisions based on data. Once students have a working reaction game, encourage students to play multiple rounds on their own with button A pressed and try to beat their best score. Then they can test with partners and see who has the fastest reaction time using button A press. If some students finish early, you can offer a few extension challenges. For example, students could add a false start penalty or option so that if someone presses the button before go appears, the program displays a message like too soon. Another challenge is to turn the game into a multiplayer reaction game where button A is one player and button B is another. Students could also add sound effects or animations when a new high score is reached. They could also change it and have no button pressed, but they could change it to on shake. So when it's shooken, or shaken, then that's when their timer will stop and they can find out their reaction time. So just to make it a little bit more engaging or fun. So yeah, they could also do tilt to the right, tilt to the left, really getting that accelerometer into play if that's what they would like.
To wrap up the lesson, bring students together for a quick reflection. You might ask them, who got the fastest reaction time today? What parts of the program helped make the game fair? How did variables and loops help the program run correctly? These conversations help students connect the coding concepts to the game they built.
So in this lesson, students combined variables, loops, randomization, and conditional logic to create a working reaction time game. These same ideas are used in many real-world programs, including video games and interactive apps. In the next lesson, students will continue expanding their programming skills by building even more interactive and complex micro-bit projects. Thanks for teaching Pine Tree programming, and we'll see you in the next lesson.